Okay, this is Chapter 9, do the getting started, where Chapter 9 deals with polygons. Okay, so let's just do a little bit of warm-up here. For each pair of grids, shade the grid on the right, this one over here, so that the ratio of shaded squares to unshaded squares is the same as the grid on the left. Well, on the grid on the left, we've got one shaded out of 3. So the ratio is 1 shaded to 3. Okay? And over here, we've got 1, 2, 3, 4, 5. We've got a total of 5. We want it to be the same ratio as this one, so that means that 1/3, 1 to 3, has to be the same as something out of 5. Now, how do we do that? Well, from previous chapters, we know that when we have an equality like this, we just cross multiply. So we get this top 1 multiplied by this bottom 5 is equal to this bottom 3 multiplied by the top question mark. So we get 1/3 is equal to x over 5. We cross multiply, so 1 times 5 is 5 is equal to 3 times x is 3x. And how do we solve for x? If we divide both sides by 3, this cancels out, and we get x is equal to 5/3. Okay? And 5/3, take your calculator, 5 divided by 3 is 1.66, or 1 2/3. So if we want to have the same ratio here, what we need to do is we have to shade in 1 2/3. So there's 1 and about 2/3, so we have to kind of guesstimate where 2/3 is. We have to take one of these squares here and divide it up into 3 equal parts, and we have to shade that in there. So it's not quite 2, okay? It's 1 2/3. So that there is what we would have to do to get the same ratio. Okay, it's a little bit less than 2, it's 1 2/3. Okay? Write the ratio of the number of shaded squares to the total number of squares for each diagram. So ratio 1, 2, 3, 4, 5 out of 6. So the ratio is 5 out of 6. Here we've got 1, 2, 3, 4, 5, 6, 7, 8, and we've got 1, 2, 3 shaded, so this would be 3 out of 8. Okay? All right. Cross out the shapes that are not regular polygons. Hint, for a regular polygon, all the sides are equal and all the angles are equal. Okay, so all the sides are equal and all the angles are equal for a regular polygon. Well, we know that this side is equal to that side, but they're not equal to that, so this is not a regular polygon. So it says cross out the shapes that are not regular polygons. So that one is not a regular polygon. This one here looks like an octagon. And we've got this line going through every side, which means it's the same, so that is one. This one here, all 4 of those side lengths are the same, so this is one. I'll just put a check mark for the ones that are. This one here we already know automatically it's not, because all sides have to be equal. This one here, that side length is equal to that side length, but it's not equal to that, so we can cross that one out. And then this one here, that side length is equal to that, is equal to that, is equal to that. So we can check that one off there. Okay? Name each polygon. Well, A, that's a trapezoid. Okay, it's not a regular polygon, but it's a polygon, because all a polygon is a closed object with straight side lengths. B, okay, we can count the number of sides. 1, 2, 3, 4, 5, 6. A 6-sided polygon is called a hexagon. Hexagon. This one has 1, 2, 3, 4, 5. This is a pentagon. And this is 1, 2, 3, 4. So we can call this this is called a quadrilateral. Okay, or it's a parallelogram. Okay, quad meaning 4. Okay, but this side is parallel to that, and that side's parallel to that, so it's a parallelogram. Okay, measure and label the side lengths of each angle measure. So take your ruler, take your protractor, get the length of this side here and that side there, and then you can take your protractor, you can calculate this angle and that angle right there. Okay, so you can use that. Okay, or what you can do is get one side measure or one angle, then you can use your trigonometry and skills that you learned in chapter 8, and you can do some trigonometry and calculating mathematically, instead of using a ruler and a protractor, calculate mathematically the lengths of and angles of these here. Once you have a couple of pieces of information, a length and a side, or two sides, or a length and an angle. Okay, number 6, write the next ratios in each pattern. So we got 1/3, 1/6, 1/9. So let's look at the pattern. The top is staying the same. What's the bottom? The bottom is going up by 3 every time. 3, 6, 9. So what's the next one? It would be 12. So this would be 1/12. And then 12 plus 3 is 15. This would be 1/15. Okay. 7/10, 14/20, 21/31. What's happening at the top? Well, it looks like it's going up by 7. So the next one would be 28. And then what's happening to the bottom? 10, 20, 30. Well, it looks like the next ratio would be 40. And then after this, 28 plus 7 must be 35. And then this next one must be 50. Okay, going up by the same ratio. Calculate these ones here. Just take your calculator. You're able to do all of this. The only thing you'd have to remember is that 4.5 is the same as 4.5 and 7/8. You can take 7 divided by 8 in your calculator and get your fraction, and then multiply it by 5. Okay? Express each measurement in the units given. 3 feet is equal to, well, this is from a previous chapter. We know there's 12 inches per foot. We have 3 feet, so 3 times 12 is 36 inches. Okay, so you can go and do the other conversions on here. You can use the charts in the back cover to do that. This is just some review. Okay. Each half of a tennis court has a dimension shown. Okay, 39 feet by 36 feet. To repave it, Chris needs to know its area in square meters. What is the length of the whole court in meters? Okay, so we have 39 feet. We multiply that by 2, so you're going to do 39 times 2, which is equal to 78 feet. Okay, and then you want to convert 78 feet to meters. 78 feet to meters. You can use the conversion charts in the back. Okay, what is its width in meters? Okay, well, you just convert 36 feet to meters as well. 36 feet to meters, get an answer. And what is the area? Just take this answer in meters, multiply it by this answer in meters, and you get your answer. So you can go ahead and do that. I don't need to do it for you. Okay, so we'll go on to 9.1.